Okay, y'all, here we are. 5.4, we're actually going to split 5.4 into 2 days. So today will be day 1, Monday we'll do day 2. Tuesday, I believe we do 5.5 day 1. Wednesday we'll review, and because Thursday is a late start, we're probably going to test Friday. Okay, so that's where we're at for right now. Thursday is a late start because we are a weak community, WEAK, and we need time in the mornings for you all to recover from 2 days after collecting candy. Okay, hold on, I'm going to pause. No problem with it. Okay, back to those of you on the World Wide Web. We took a little pause there. Maureen wanted to vent, so we did that. Here's a tennis ball lab. You know the deal on that. Let's talk about inequalities and absolute values. Okay, let's go with number 1 here. Okay, look at number 1. It says, where is f of x and g of x equal? Oh, well, I know where f of x and g of x are equal. Where are my special little tools here? Where's my star? There's my star. Okay, so for number 1, I'm going to say, bam, right there. Where? There. Where'd it go? Where'd my star go? There it is. Come on, work. Why isn't that working? But I just went on shape. Oh, I have to draw it. That's right. Oh, dang. Wow. Wait, we just wasted like 30 seconds on that. Okay, there's where they are equal, right? And that's where x equals what? Oh, gross. I'm not sure. Let's say, sure. Let's just make it a nice even 4, right? Okay, so in number 2, we know that they're equal at 4. So where would f of x be less than or equal to g of x? Well, f of x is the line. Where would it be less than or equal to g of x? Well, for the second part, we would say anywhere that the red line is below the blue line, it'd be true. Right? So for our domain of that, we would have an open circle at 4 because they're equal there. And the answer to this would be negative infinity to 4. Okay, likewise, in the third example, I want to know where f of x is greater than g of x. So what would be our answer there? 4 to infinity. How would these things change if I would have said less than or equal to? Yeah, we'd have a closed bracket where they're equal. Okay. So now we're going to be looking graphically at a couple of different sketches. We're going to be determining where is one greater than the other. And of course, this is going to be the most basic of the examples. Okay. This slide basically says greater than means larger. Less than means smaller. I don't know why this is on here, but basically if you wanted a mathematical breakdown in f of x, g of x jargon, there you go. Sound good? Very little time spent on that slide. That's great. I gotta hold this thing, otherwise it's gonna. Here we go. Okay, I'm not gonna get all fancy with this with the stars and the red and the yellow. I just want to look at and determine the answers to these. So where are f of x and g of x equal to each other? X equals -1 and x equals +1. Okay, if we can agree on that, let's move on. So now let's solve where f of x being the absolute value function, is less than g of x. Well, is f of x less than between -1 and 1 or on the outsides of -1 and 1? Well, let's take a look. Here's f of x. Oops, excuse me, this is g of x. So g of x is less than in between. Here's f of x, right? F of x's outputs are greater than that. Oops, excuse me. Go back. Okay, the red is below the blue, between -1 and 1. We want to know where is the blue less than the red, okay? Where is the blue less than the red? Well, we would say outside of these values. All right, so the blue is less than the red. Let's give it a domain. Negative infinity to what? Negative 1, unioned with 1 to infinity. Those of you at home, why don't you look at number 3, pause the video, come back, and we'll have a domain for the third part. Okay, so check your answer. Can we agree negative 1 to 1 inclusive on those endpoints? All right, you will be marked wrong if you put parentheses instead of square brackets. Okay, but the blue graph, f of x is greater than or equal to the red graph, g of x, on the domain negative 1 to 1. Okay, so let's get to something a little bit more funky here. All right, so now let's talk about some value and a function. Yeah, see, I hope you understand that this is not me trying to say this is you and this is me walking away with all the cash, okay? I mean, I'm trying to bring you this knowledge. No, I don't know what the explanation of that is, other than we know what their absolute value will be at the bottom of that, whatever that is. It'll probably have like nice squishy foam cubes and pudding and yeah, pudding, because it's soft, and then it'll probably taste good. You're running your recording. Oh, I am running this, aren't I? Oh my gosh. Okay, let's do a couple of these. I'd like to do the most filthiest, but I do want to start with the first one. Let's graph 3. Oh, hi 3. There's 3. Right. Can we say that's y equals 3? Yeah. I want to know where the absolute value of x minus 1 would be greater than or equal to that. Okay, now first I'm going to do it by sketching it, because it's really easy. Right? Oh, okay. There's absolute value of x minus 1. So I want to know where absolute value x minus 1 be greater than or equal to 3. Okay, so I'd be going like that and like that. Oh, this is too easy. I just got to find that x value. And I just got to find that x value. We'll call that x1 and x2. And then I'm pretty certain that it's going to go from negative infinity to x1 and close that bracket, because we know greater than or equal, a union with x2 to infinity. So how could I find x1 and x2? Oh, I could just do some algebra. Oh, so x minus 1 be equal to, now be careful here, be equal to 3, or negative x minus 1 be equal to 3. And I can solve. So that means x equals 4, or negative x plus 1 equal 3, which mean, so that negative x equal 2, so x equal negative 2. Oh, too easy. Close those brackets. Don't be forgetting that. What was that? X equals 4. So 4 to infinity. You could always test these numbers. Test 4. Let's see if that works. What if I plug a 4 in here? 4 minus 1 is 3. Absolute value of 3, is it greater than or equal to 3? Yeah, it's equal. Oh, it's equal. 5 would work. How about negative 2? Negative 2 minus 1 is negative 3. Absolute value of negative 3. Is 3 greater than or equal to 3? Chow. Right? Are you tired of my country voice? Okay. Okay, pretty good? Let's get to one that's nasty. Yeah, let's do 3 and 4. How about both of those? Let's do 3 and 4. Okay, I want to show you an alternate way to do this. Alternate way. Okay, I'm going to set up 2 inequalities. Okay. X minus 1, absolute value of x minus 1 is greater than 2. And the other inequality would be absolute value of x minus 1 is to be less than or equal to 5. Okay, now I showed you the equal to method before. I want to show you what I think might be the easier method here. Okay, so let's set up 2 inequalities for the left absolute value inequality. So 2 is less than x minus 1. What would the other one be? 2 is less than. What's the other inequality? 2 is less than x minus 1, and 2 is less than negative x minus 1. Okay, let's solve them. Okay, so that would be x is greater than 3. Okay, sweet. Well, I got to distribute the negative on this one, so that'd be negative x plus 1. Ooh, now be careful here. I get 1 is less than, or negative x, but what happens when I divide by a negative? Flips that inequality. Oops, that should be a negative 1. So I know x is greater than 3, and x is less than negative 1. So let's just go with me for a second here. Negative infinity to negative 1. That's this interval, right? X less than negative 1. Or x greater than 3. That gives me that interval. Is everybody okay with that? Let's take a look. Those on the World Wide Web, I came up with an answer here of negative infinity to negative 1 unioned with 3 to infinity. All that says is that this thing right here, absolute value x minus 1, is greater than 2 to the right of 3 and to the left of negative 1. All right, now I'm about to restrict it on the top end too. And you might be able to do this mentally, but I want to talk through the algebra in it. I'm going to put that there. So you might already be anticipating I'm going to have a couple of spots where it gets lopped off, right? I want it to be between those two values. So let's come up with those two values. You can make a hypothesis on it, but I'm going to go ahead and do it right here. So I'd say that x minus 1 is less than or equal to 5, and negative x minus 1 is less than or equal to 5. So I solve, I get x is less than or equal to 6, and negative x plus 1 is less than or equal to 5, so negative x is less than or equal to 4. So x has what relationship to negative 4? Greater than. I'm going to flip that absolute value sign, and I get that. Okay, so what I've determined now is this. What's that value? That's negative 4. What's that value? What did I say? 6. Sweet. So I have my final domain in which this, and I'm going to use purple, even though I don't like purple that much. In that domain right there, the absolute value of x minus 1 is greater than 2, but less than or equal to 5. So let's put an answer down, and let's see where, if you can find my mistake. What's my mistake? Barrett, do you see it? So tell me, I've got parenthesis, 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 parenthesis. Tell me the order that it should be. Yeah, good. Because you see this right here? Right? That's on the lower end, which is right here and right here. So those should be open, right, at negative 1 and 3. And I see this right here. That's on my upper end, so that should be closed and closed. So that's why I have a bracket here and a bracket there. Okay, it's good stuff. Let's pause this.